Greetings, one and all. Today we are going to discuss about Neil Bohr Atomic Model. Previously, we discussed about the defects of Rutherford Atomic Model. That in that atomic model, he described that electron is revolving around the nucleus in an orbit in a circular pathway, but he didn't describe how is it moving, what kind of energy is required, how is the energy consumed, and is it causing any sort of momentum or not. Nothing was described. After which there was another theory, electromagnetic theory, which told that electron is revolving around the nucleus, but as it is revolving around the nucleus due to the attraction of electron and proton, it is causing to release energy. Due to attraction of electron and proton, it is causing to release energy, and that energy is decreasing the energy of electron. It is releasing energy due to which its own energy is decreased. As its energy is decreased, the electron is arranged. Let me just draw it over here. Oops. uh, this energy is causing that orbit of electron, causing that electron to travel in a spiral orbit, and this model is known as a spiral model. This model, which was proposed by George Maxwell's electromagnetic theory, is known as spiral model, and that model, which was proposed by Rutherford atomic model, is known as circular model. And in a spiral model, as it was saying that energy is continuously decreasing due to which it is forming a spiral shaped orbit. Once there would be a time when the electron will collapse with the nucleus and thus cause to end the life of atom. So that was not possible at all. But after that, there was another scientist named Neil Bohr. Neil Bohr was a scientist, was a chemist who came with the idea that electron is revolving in a circular path. Electron is revolving in an orbit in a circular path, but it is not emitting energy, which means it is not emitting energy even though it is revolving around the nucleus in a circular path. It is not emitting any sort of energy. Why is it not emitting any sort of energy? Because this is nucleus, and that is what we call as electron. So now, when we know that nucleus is positively charged, electron is negatively charged, both attract each other due to opposite charges. As both of these attract each other, that causes to produce a force between electron and proton known as electrostatic force of attraction, or the centripetal force, as we are having a centripetal force inside the circle we are having centripetal force, which causes the object to come inside the center of the circle. So here we are having the same thing, centripetal force, which is asking the electron to come inside towards the nucleus. But there is an equal amount of force, but in the opposite direction, which is known as a centrifugal force, which is causing the electron to go outside, which is known as centrifugal force, which is asking the electron to come outside and out of the atom, and that type of force is known as centrifugal force. Now, centrifugal force is due to the electrons, centripetal force is due to the attraction of electron and proton. Centrifugal force is possessed by electrons. As electron is a highly energized excitable particle, it is due to the electrons highly excitability that it is causing the centrifugal force. Now, inside an atom, the centrifugal force and centripetal force are equal. Centrifugal force and centripetal force are equal. Centrifugal and centripetal force are equal, but in opposite direction, due to which they do not cause electron to release energy whenever it is traveling inside the atom. Secondly, what he decided was that here um he told that uh, the electron is having charge, it is having charge, it is having mass as well, apart from atomic mass. So here, as it is having charge and mass, it must have momentum as well. It is having charge, it is having mass, it is having uh, velocity because it is moving, so it is having velocity. Of course, if it is moving, there would be some sort of velocity. So this electron should have possessed momentum as well. We are going to discuss how we are going to derive the equation for momentum of electron, but here first he gave the concept that electron is revolving around the nucleus in the form of orbit without release of energy. So electron, when it is moving inside the orbit, it is moving circularly, angularly. But when electron is not releasing energy, he told another condition that there is a possibility that electron can release energy. The electron can gain or release energy. There is a condition that electron can gain or release energy. What was that condition? That condition was such that here, for suppose we are having an atom, and inside that atom Um, so suppose uh, we are having two shells of an atom. There is another shell as well. So here there are two shells. Now, for suppose there is an electron. There is an electron here. Now this electron wants to jump in from the inner shell to outer shell. So he first described that the inner shell is having less size. Inner shell is having less size because it is well near to the nucleus. It is having less size. As it is having less size, so he also described that as it is having less size, it is having less amount of energy. Secondly, the outermost shell is having the most size because it is away from nucleus. It is having most size, due to which it is having the most energy. It is having the most energy. After which, uh, this is a nucleus, of course, and here we are having electron, and it is having more energy than innermost shell. So if electron wants to jump from inside to outside or outer to inner shell, then and it is a possibility that electron can release or gain energy. Now electron is moving from downward to upward shell. As it is moving from downward to upward shell, it will require energy to jump from downward to upward shell from low energy to high energy level, and that utilizes energy. It requires to utilize energy, and thus as it utilizes energy, the energy level is increased inside the electron, and this effect is only obtained by the heating effect. Secondly, if an electron, for suppose this is an electron, and this electron present inside the outermost shells, it wants to go inside the innermost shell, for suppose in this shell. So here, in order to go from upward to downward shell, in order to move from high level energy to low level energy, it will release energy, which means its energy will be decreased, and that requires cooling effect. So there was a drawback of Neil Bohr, that here Neil Bohr utilized uh, the correct theory, but here he utilized a condition that he would be always utilizing the hydrogen atom, which means any atom which would be having its number of electron as 1 would be applicable under the Neil Bohr atomic theory. So here we are come together. We are here for discussing further part. As we know, this is atom. This is atom. This is nucleus. A bit small, but nucleus. It is electron. And now this pathway, this distance in which the electron is traveling around the nucleus, is the pathway. Is the circular orbit or pathway in which the electron is traveling around the nucleus. Now this pathway, for suppose this pathway, if it is cutted half, so it will become pi. A complete circle is known as 2 pi, and this is half circle is known as pi. Secondly, if we are uh, providing, for suppose we are having, if we are having a line here, if we are having a line over here, or we can also consider that as a distance between electron and nucleus. For suppose we are having distance between electron and nucleus, so this distance between electron and nucleus would be considered as what? It would be considered as a radius. As we know, what is a radius? It is the distance between electron and nucleus, or distance between the two, between the center of the circle to the circumference, half the distance between the center of the circle and the circumference, so it will become pi r. But now we want to calculate the distance, or suppose we want to calculate the distance of both side of radiuses. Now this is radius, this is radius as well. So in order to calculate both sides of radius, we can write it as 2 pi r, or we can simply write as pi diameter, because 2r is equals to diameter, and this complete half of circle is known as diameter. So here, this is what we call as the distance covered by the electron, or we can also call it as the circumference of the orbit. So here, this is the first equation. Secondly, as we know that we are having electron is possessing charge, mass, it is moving because of energy. As it is having kinetic energy, it must have velocity. As it is having velocity, we can also say that it is having momentum. So momentum is equals to what? Momentum is equals to mv. Momentum is equals to mv. But as it move, electron is not moving linearly, electron is moving angularly. The angular momentum is having its formula as mvr. mv into r. What does r represent? R represents the radius again, or the distance between the electron and nucleus. So here, after that, what we could write here is that we are having moment, angular momentum distance, but we need a condition here which is known as the action of an orbit. What is the action of an orbit? Its ability to revolve around the nucleus. So it is the action, and action is equals to momentum, angular momentum, of course, angular momentum into angular momentum into distance. So what is the value of action? Action is equals to nh is equals to angular momentum is having its value as mvr into distance is having its value as 2 pi r. So now um, n represents the number of orbits, h represents a Planck's constant, which is having a constant value 6.606 into 10 to the power minus 34. After which, after multiplying both of the conditions, we are supposed to move. Oops, we have made a mistake here. That action is equals to momentum only. Action is equals to momentum only, so it will become mv into 2 pi r. So here, action is equals to momentum into displacement, due to which when we are going to multiply both of the conditions, we have our answer as nh upon 2 pi is equals to mvr. Now this is the formula for angular momentum, and that angular momentum is represented by nh upon 2 pi, and yeah, that's the formula here. And that is obtained whenever we are gonna multiply the momentum with displacement. We have answer as this: more linear momentum into displacement is equals to nh. Now after simplification, that is our answer, and we are equals to nh upon 2 pi. Hopefully you enjoyed the video, and we'll meet again with another